Okay, so we're back to talk about appositional growth. And when you think appositional, think how close it sounds to oppositional. And you'll remember that this is the growth that occurs in kids and teens that helps your bones grow in length and in width and proportionately. Proportions matter. Okay, so let's get down to it. First, you have active areas of growth. And so those active areas in long bones are the epiphyseal plates. These are what are going to help your bones extend in length. Cartilage here forms continuously in that open band, and that is where we're going to get a constant supply of cells to ossify. And that's going to be due to the activity of osteoblasts, right? They're going to be converting that new cartilage on a regular basis into new bone. And so as we add more new bone in those little areas, we're extending the length of the diaphysis, as you'll see in the next slide. Osteoclasts are going to be simultaneously working to maintain the shape of the medullary cavity and to help reshape the epiphyses so that they still have their distinct little nubbin ends and projections for muscular attachment. And let's look at that in this diagram. So this might be a little bit complicated, but most of these diagrams are. If you look at both of these, this is kind of the before, and then this is kind of the after photo. Okay, so on this side of the diagram, we're looking at before growth, and then this is the after growth. And so you can see where the shape of the old bone was in this dotted red line. This is continuing the outline of the bone on the left. Okay. And so here's what's happening in this particular image. To increase the length of the diaphysis, the long part of the long bone, if we were to just draw our long bone, if I wanted to increase the size and I just added to the outside all the way around and continue to go around the shape, I want you to notice some of the problems that arise. One, even though my drawing is not super great, you can probably start to see that the definition that I had around the first set of epiphyses is kind of going away, and it's starting to look more like a blob than anything else, right? And you can really see that if I start to erase some of the interior, right? This no longer has that same shape of the bone that I started with, and that's a problem because form indicates function. Shape matters in terms of how these things work. The other thing that we note is that if I just added to the outside, we would be stuck with our baby medullary cavity that would be too tiny. It wouldn't have extended in length and it wouldn't be proportionate, right? I want to maintain the same thickness of compact bone. I don't want too thick of a compact bone. It really needs to extend for a bone this size out this way. And so this is this idea of having to maintain proportions within and without. And so how do we do that? Well, here's one of the ways. First, what we have to do is create some sort of elongation. And that elongation is going to happen at the epiphyseal plate. We can see that here. There's the hyaline cartilage in teal. As we look at the growth that we see, if you go to the after page, right, you can see that the additional tissue grew in this region below the plate. And so that means that new cartilage is being deposited at the top of the epiphysis. And the last set of cartilage cells along the bottom of the diaphysis, well, they solidify into ossified bone. and then I create another layer of hyaline cartilage, and then I solidify some more ossified bone. And so this way my diaphysis is getting longer as my new layers of cartilage push upwards. And so I'm always adding bone to the bottom. Add bone to the bottom, add cartilage to the cap. And then more bone ossifies in at the bottom, and more cartilage to the cap until now we're even with the afterbone. And so all of this has filled in. But notice that the other difference between our before and our after is that I drew solid bone in this area, just like in my original drawing. And so I need to carve some of this out. And so my osteoclasts are going to come around, and they're going to carve away some of this bone towards the inside where the medullary cavity would be. And they'll leave the outer part where the outer compact bone should be. And so that's the way we're lengthening the diaphysis. So the diaphysis lengthens at the epiphyseal plate. But there's another place that needs to lengthen. Remember that the outline of our epiphyses, our nubbins, became kind of generalized and lost their shape. So those outer details, the shapes of the epiphyses, whatever they are, these details have to be grown from the exterior. And so we need a line of active cartilage around the outside that will grow exclusively over those regions. And that is the band of teal that you can see here at the top, right? And so here at the top, you'll have a layer of ossifying tissue. So osteoblast activity is at the bottom again, and new cartilage is growing around the exterior of the epiphysis. So the same thing that's happening at the epiphyseal plate is happening at the tops or the ends of the epiphyses as well. And that's how we're maintaining the shape of the epiphysis. Now, this is going to stop eventually when you are mature, and this upper region of cartilage will no longer be reproductive and no longer have stem cells that are active, and just exist as a band of cartilage that conveniently helps protect the ends of your long bones in joints. So that becomes the articular cartilage. And so that describes the lengthening of the bone. And so what we still have to do is talk about how does a bone increase in its width, right? So I'll get my crazy pen under control. And in order to increase your width, what we need to do is add to the outside edge. And the only way that we're going to do that is remember that we have a membrane that exists from the bottom of the articular cartilage all the way around the diaphysis. And this outer membrane was the periosteum. And inside the edge of the periosteum are, guess who? Osteoblasts. And they exist in a very thin membrane. I'll just kind of draw it over here a little bit bigger. But these osteoblasts are able to lay down just some thin layers of cells to expand the width of your long bone. And as they add width, remember that if your long bone is narrow and skinny and you just add width, then your bone becomes nice and fat, but too heavy and too dense. And so we also need to enlist the help of our osteoclasts to continue to carve out the middle. So as your bone becomes wider, you still maintain the right width of compact bone along the diaphysis. So again, paired activity. And so that's how we do appositional growth, and that will subsist as long as there are hormones driving that system, and those hormones basically slow in production around the age of 20 for most people.